In this video, we're going to talk about ideal gas and the ideal gas law. In the previous video, we talked about the simple gas laws, which was Boyle's law, where volume and pressure are inversely proportional. Charles' law, where volume and temperature are proportional. And Avogadro's law, where volume and number of moles are proportional. And if we put all these together, you see we have volume all on one side. We can say volume is proportional to number of moles multiplied by temperature divided by pressure. Now, we don't want that proportional sign because we can't do math with proportions. We can only do math with equal signs. So to get rid of this proportional sign from the last slide, we need some kind of constant. And we're going to use what's called the ideal gas constant. And it's just a number. It's not a number you have to memorize. If you ever have to use the ideal gas constant on a test, I will give it to you. But you can see the ideal gas constant has some pretty interesting units. So the two ideal gas numbers we're going to use, it's either the liters atmosphere per mole multiplied by Kelvin, or the liters multiplied by kilopascals divided by Kelvin mole. And so the ideal gas law, and an equation we will be using quite a lot in this chapter, is PV equals nRT. That is pressure multiplied by volume equals number of moles times this ideal gas constant, R, times temperature. And PV equals nRT is really just combining the three simple gas laws and introducing a new constant. You can see that all three ideal gas law or simple gas laws are being followed in the ideal gas law. So let's try to use this ideal gas law. So let's say we're in a classroom that's approximately 3,600 cubic feet. Let's say we're at room temperature and we're at sea level, so 1 atmosphere. How many number of moles of ideal gas is in this room? So here's a gas constant for you to use. You're gonna want to convert from feet to meters and meters cubed and liters, because look, the gas constant is in liters. And this is the equation you want to use, the ideal gas constant. So try and solve that equation, pause the video, come back when you have an answer. Alright, let's take a look at how we do this. So the first thing is our conversion, 3,600 cubic feet. 1 foot is 0.3048 meters. And remember from way back in the beginning of this course, we talked about how we convert volumes. Since we have cubic feet and only 1 feet here, we have to do this a total of 3 times. So we have feet times feet times feet gives us cubic feet, cancels out this cubic feet. And so now we want to convert to liters. 1 cubic meter is 1,000 liters. So our volume in a classroom is 101.9 liters. Alright. Now we want to convert our temperature from 25C to 273, our 25C plus 273C to 298K. We want it in K because, again, our gas constant is in K. We want our units to cancel out. Now let's set up our ideal gas law. Pressure times volume equals N. N's are unknown, that's what we're trying to solve, times R times temperature. So what I'm going to do is I'm going to divide each side by 8.314 times 298 to get N alone. And that's what this looks like. Now let's take a look at how the units. We have atmosphere and atmosphere. Those cancel out. Liters times liters. Those cancel out. K times K cancel out. So our units are moles. And so our answer will be in, not atmospheres, that's a typo. Our units will be in moles. So our answer is 0.0411 moles. And that is how we use the ideal gas law. And that is it for this video. Sorry for the typo, but I'll see you in the next video.